Okay, how are you doing so far? We'll now move on to question 19. So, it's important to think of two stages, the rain and then the ounce. That's how we're going to set it up. Don't mix up both at the same time. So first, it can either rain or it can not rain. So we'll have that first branch here, rain or not rain. And then if it rains, well, there can be ants or there may not be ants. If it doesn't rain, it can also be that Jim's disturbed by ants or not ants. So we'll symbolize this as A, not A, A, and not A. Remember, we have to write the probabilities along the branches. The probability that it rains is 0.7. That it doesn't rain is therefore 0.3. That needs to add up to 1. The probability that he's disturbed by ants is 0.4. So the probability he's not disturbed is 0.6. And of course the same here. And remember, along the branches we're going to multiply. So for example here 0.7 times 0.4. Let's write this with a times sign like that. 0.7 times 0.6. 0.3 times 0.4. And 0.3 times 0.6. So if I answer question B, what's the probability that it is raining and Jim is disturbed by ants? I need to go and look for the right branches or branch that is concerned by this. So it's raining and Jim is disturbed by ants, so they're ants. So it's actually only this branch that it's talking about. So what we'll need to do simply is to multiply this out and we get 0.28. Okay, that's the probability that it's raining, probability of rain and ants at the same time is 0.28. All the other things concern other outcomes. In question C, we're looking at the question at the probability for there to be rain or ants or both. So let's use our tree again. Rain is here, so then that concerns both branches, and regardless of whether there are ants or not, it will rain. So we're going to tick this one, that one, okay, and then there can be no rain but ants. That's what this says here, rain or ants. Both rain and ants is covered here. So we've got these three branches which cover this event here. So one shortcut here, we can see that it doesn't cover this case where there's no rain and no ants. So one shortcut of calculating the probability here, okay, would be to say that the probability will be 1 minus the probability of no rain and no ants. That's easy enough to calculate here. 0.3 times 0.6 is 0.18. So we do 1 minus 0.18, which is equal to 0.82. And you'd get the same answer, obviously, if you add this probability here, plus the one you'd calculate here, plus the one you'd calculate here. Let's move over to question 20. Now, this is clearly about trigonometry, but you've got to remember that trigonometry, basic trigonometry, can only be used in right angle triangles. And so I must find a right angle triangle. One possibility is this one here. You cannot use all of the triangle, and so you see that this angle will be cut in two. Now it says that 0.5 is delta, so this must be 0.25 degrees. and it says that this distance here from Earth to Moon is 300,000 kilometers. And so we're looking for the right ratio, which will involve this distance here. Watch out, that's not D, but let's call it R for the radius. Okay, and so we'll set up tan 0.25 degrees equals to R over 300,000 kilometers. And so you'll calculate R, and then remember to multiply it by 2 in order to get the distance D. Please finish that question. And now over to question 21. So when we have a formula here and we want to be using this, can you see that it says equal to 0 here, which is not the case here. So we'll first have to rearrange the equation to obtain 4x squared minus 3x plus 1 equals to 0. We've subtracted 1 on both sides. And now I can identify the values of A, B, and C. Let's do that here. It's a good idea to actually write this out. A equals to 4, B equals to negative 3, C equals to 1. And now we can substitute into the quadratic formula. Let's do that here. Now watch out, because this was a source of many mistakes. Careful with this bit here first. It says negative B. Now B is in itself a negative number. Best to really just substitute in here using brackets. Okay, and then we get plus minus. And watch out now, this is the second source of mistake, B squared. So again, just stubbornly substitute without much thinking. B is negative 3, and we need to square this. You must make sure there are brackets here or things will go wrong. And then we'll have A is 4 and C is 1. Note that I use brackets every time I substitute. And then down here we have 2 times 4. And if you simplify this, you'll get, see, this becomes positive 3 plus minus, and you should be getting a negative 7 in here. 8. Now, clearly you can see there's a problem here. Okay, negative square roots don't exist. Well, actually, the square roots of negative numbers don't exist. That's what I should have said. Okay, and therefore there's no solution. And if I now try to answer question B using my graphics display calculator, I can type in the equation of the function. I can then graph it, and then you see that the parabola doesn't intersect with the x-axis. Such a parabola does not have solutions to the equation where it's equal to 0. And so you can simply record your answer like this. You do a very rough sketch. You kind of sketch the parabola and you show that it doesn't intersect with the x-axis. And you write something like this: doesn't intersect with x-axis. And therefore that confirms our result from the question before. Okie dokie, let's go to question 22. Question 22 is relatively straightforward as long as you recognize that 4 and 256, both of these numbers are powers of 2. Once you recognize this, you can actually express these as powers of 2. You can say, well, that's going to be 2 to the power of 2, and that's going to be 2 to the power of 8. 2 times 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 2. And so we can rewrite the equation. This is going to be 2 to the power of 2 in brackets to the power of n. So you have substituted 2 to the power of 2 instead of 4. And here also, I've substituted 256, I've substituted 2 to the power of 8. And therefore, applying a few indice rules, I know that here I can multiply, so that's 2 to the power of 2, 2n. And here, I know that 1 over something, then I can rewrite this with a negative index. And by comparing the two, I can now see, well, this has to be equal to that, because the base here 2 is the same. That's the only way they're going to be equal. And so I can write out the equation 2n equals negative 8. I divide by 2. I get n equals to negative 4. And that's it. N is minus 4. Go ahead and check that in here to see if you did that rightly. Now over to question 23. So we start with a rectangle of a perimeter 40, and I need to be using algebra. So let's draw a rectangle, and we could label this x, could label this y, and then straight away for the perimeter of the rectangle, and because we're talking about perimeter here, we can write an equation. 2x plus 2y equals to 40. This plus this plus this plus that must be equal to 40. And I'll call this my first equation. Then we also have a square somewhere. So let's draw in a square. All sides are the same length. And we obtain a square if we reduce one side by 5, so the x, we take away 5, so it's a bit shorter, and also we take y, add 5 to it, which makes it a bit longer, so y plus 5. Okay, and well, it says that we get a square if we do that. Now, using the idea that the two sides are equal, we can then say, well, this has to be equal to that. And so we get a second equation out of this sketch that x minus 5 must be equal to y plus 5 because it becomes a square. And so I've got now two equations. I'm just going to copy this one over here. Well, first let's rearrange this a little bit. I can, for example, subtract y and add 5 to both sides. I'm getting x minus y equals to add 5 to here, becomes 10. So I'm getting second equation, x minus y equals to 10. And now you can solve this using your favorite method for simultaneous equations. Go ahead and do that. And now over to my favorite question. Okay, so first thing, notice that I'm talking about coordinates here. And clearly the obvious thing to do is to actually build up a coordinate system. Then I can understand the question better. You'd be amazed at how many students try to solve this question without actually producing a graph. So let's go ahead. I've got the point A here at 4, negative 3, and point B is at negative 2, 5. Now, that is one side of a triangle. I now need to find a point C so that the area is 48. Now let's make it simple. Areas of triangle, I need to do base times height divided by 2. But base and height have to be perpendicular. Okay, so where can I find easily perpendicular lines here? Well, of course, the easiest idea would be if it worked for a horizontal and a vertical and a horizontal line. So here I've got a right angle. And now it's already much easier to think in terms of base times height divided by 2, because if this was my base and this was my height, let's see how long this would be. This goes from minus 2 all the way to 4, so this would be 6, and this goes from negative 3 all the way to 5, so that'd be 8. Okay, now 6 times 8 is, 48, and I need 48, but hang on a minute. The area of a triangle is base times height divided by 2. So actually the area of this so far at the moment is 48 divided by 2. But I want 48, so I need a base that's twice as long. Simply make this go in the other direction. 6 steps in the other direction, I'll get to, well, -2, I will get to -8 here. Okay, -8. And then I can close my triangle, right? And so if this was 12 here, 6 plus 6, then the area would be 12 times, but the height stays the same, that hasn't changed, 8 divided by 2, and that is 48. We've done question A. Now, question B. Perimeter of the triangle. And we need to find another point, so that's point C here. Now we need to find another point so that the perimeter is 24. Watch out, it's not the area this time, it's the perimeter. Now, for the perimeter, we need to be adding the three sides for it to be 24. Well, let's play around a little bit with this. We've got a triangle already here. We know how long this is and how long this is. We can actually find out how long this is by using Pythagoras, because 8 squared plus 6 squared must be equal to that other side here, squared. Okay, and you'll soon find out here that x is, well, this is 100. So x squared equals to 100 and x equals to 10. So this is actually 10. Now hang on a minute, 10 plus 8, 18, plus 6, 24. That means I'm done already. This must be point D. In this one here, that's an example where the perimeter is 24. Now, of course, there'd be many other examples. For example, that I could put a point up here somewhere and have this triangle. It'd be exactly the same. So different solutions, but this will do fine here. So that's this question done. So how did you do in your exam revision? I recommend you take notes and you try every question that you did wrong. You try to correct that on your own, and then you produce a neat copy of all this and then submit it to your teacher. That's the best way to improve. Keep trying again and you'll be doing fine. Good luck with that.